Okay, hi guys. So we'll be starting off our first lecture in the physical chemistry video lecture series. Okay, so let's get started. So first we'll be starting off with a very important chapter which is known as stoichiometry. Okay, stoichiometry. Okay, so let's get started. So first let's define what's a matter. So matter, plainly put, is anything that occupies space and has mass is called matter. So space plus mass is matter. Okay, so now let's discuss states of matter. States of matter, as you have already would have studied it in your previous classes, is solid, liquid, gas. uh, some of you who may not know beyond that, then uh, we are going to discuss about two more states, which is plasma and Bose-Einstein Condensate. Okay, so we have solid, liquid, gas, plasma, and Bose-Einstein Condensate. Okay, now let's define, or rather understand all these states. So solid is nothing but definite mass matter, which is definite mass and definite volume. Okay, liquid is nothing but no liquid has no fixed shape, but obviously it has definite volume. So no fixed shape, but definite volume. Okay, what about gas? Gas has again no fixed shape, but has, and also it has no definite volume. Okay, what about plasma? Plasma, so plasma matter exists at very high temperature, and at such a high temperature atoms convert into ions. So exist at high temperature. Okay, and at that high temperature atoms convert itself into ions. Okay, what about Bose-Einstein condensate? So for Bose-Einstein condensate, it exists at low temperature, and gaseous atoms combine together to form a new particle called BEC, or Bose-Einstein condensate. So it occurs at low temperature. So this is high, I forgot to write temperature. Okay, so symbolically I have represented high with the upward arrow, high temperature. Okay, and here I will be representing again downward arrow for low temperature, for low, and I'm writing temperature here. So at low temperature gaseous atoms combine to form new particle known as BEC particles. Okay, so now let's discuss the chemical classification of matter. Okay, chemical classification of matter. So in the chemical classification, again we can classify them as mixture. Okay, mixture can be again homogeneous or heterogeneous. Homogeneous and heterogeneous. So we can have some compounds. Compounds can be organic or inorganic, and we can have elements. Elements can be metals, non-metals, metalloids. Okay, or we can have metalloids as well. Metalloids, single T. Okay, so next let's get into the definition of an atom. So atom is smallest particle of an element which contains definite characteristics and chemical properties of an element is a atom. Okay, so atom may or may not have independent entity. Okay, so let me just write it in points that it is the smallest particle of an element. Okay, contains definite characteristics and chemical properties. And chemical properties of an element, obviously. Okay, and they may or may not have an independent identity. Okay, may or may not have independent identity. Okay, so please remember for a note that gaseous mixture is always homogeneous. So example of I'm just writing example of a homogeneous mixture is a gaseous mixture is always homogeneous. Okay, and let's actually, after atom, let's define what's a molecule. Okay, so molecule is the smallest unit of a compound, uh, which compound or element which contains definite properties or rather chemical properties. So they may have one or more than one type of atoms in it. Okay, so and molecules have independent existence. Okay, so smallest unit of compounds, those compounds can sometimes be elements as well. Okay, have definite chemical properties. Okay, then have one or more than one type of a single molecule can contain one or more than one types of atoms or elements in it. Okay, next they have independent existence. Okay, so now let's delve or dive into the most important concept of physical chemistry, which is mole concept. I will try to make this concept as simple as I can for you guys. Okay, so first let's define some key definitions and concepts for it before going forward. So let's define one AMU first. One AMU is 1/12 mass of carbon 12 atom. Okay, so if we go into the calculation part, then so as to derive the mass of carbon C12 atom, so the mass of one atom in a carbon would be, so let's derive it. So on a side, I'm just calculating the mass of a single atom, so you can just, this is the Avogadro number. Okay, so we'll be seeing this in a short while. So 6 into the 6 into 10 to the power 23 atoms are there in a single or 1 mole of carbon C612. So these are the number of carbon atoms. Okay, so in 1 mole of carbon, so which is equal to, and the mass of carbon is 12. Mass of 1 mole of carbon is 12 gram. Okay, so what would the mass of one atom? Mass of one atom would be 12 divided by 6 into 10 to the power 23 gram, or in other words you can say that mass is 2 into 10 to the power minus 23 gram of one atom. Okay, so what is the mass of one C612 atom, it would be mass would be 200 times power minus 23 gram. Okay, this is the mass of one carbon atom, and 1 AMU is 1/12 mass of one carbon atom. Okay, so divide by 12, so which gives us 1.66 into 10 to the power minus 24 grams. This is 1 AMU. Okay, so we can say that atomic mass of C612 is 12 AMU. Okay, and molecular mass of let's say oxygen would be 32 AMU. Okay, so let's see next concept, which is relative atomic mass or relative molecular mass. Relative atomic mass, atomic or molecular mass. Okay, so we can say that mass of an atom divided by 1/12 mass of C612 atom would be atomic mass upon 1 AMU. Okay, similarly mass of a molecule divided by again 1/12 mass of carbon atom is again molecular mass divided by 1 AMU. Okay, so what is the mass of an atom then? Mass of an atom is simply, you can say that it is the mass of all the particles or subparticles available in an atom, which is neutrons, protons and electrons. Okay, so which is roughly mass of neutrons plus protons, because mass of electron is very negligible. Okay, and before ending this lecture, one more important note, that whenever you have to calculate the average of atomic masses of isotopes, then it's equal to the atomic mass of an element. Okay, so average of atomic mass of isotopes is equals to atomic mass of element. Or rather, you can say it vice versa as well, that if you want to calculate the atomic mass of an element, then you have to take the average of the atomic masses of all the isotopes of that element. Okay, so with this we come to the end of this lecture. In the next lecture we'll be continuing on seeing some more concepts on mole. Okay, so till then, good luck and goodbye.